Just a few kilometers off the Chinese coast lies a region of the ocean where the wind can change direction within minutes. Underwater currents collide like invisible rivers, and gigantic steel platforms look like toys against the sheer force of the sea. For decades, navigators avoided certain areas of the South China Sea because they believed storms could appear there without warning, swallowing entire vessels before radar systems even detected danger. Today, in this exact environment, China is attempting one of the most ambitious projects in modern history. A colossal corridor designed to connect artificial ocean cities, automated ports, and railways crossing the frozen mountains of Tibet. The goal looks simple when shown through digital animations on state television. Build structures over the ocean, expand artificial islands, and connect everything through high-speed rail networks. But reality has started to terrify even the country's most experienced engineers. The more the studies advanced, the more extreme phenomena, unexpected geological failures, and natural movements began putting billions of dollars at risk. For the first time in decades, some specialists started raising a disturbing hypothesis. Perhaps there are places on Earth that were never meant to support permanent human structures. The idea was born quietly in the early 2000s. China's economic growth was transforming its ports into massive bottlenecks. Cargo ships piled up daily waiting for authorization to unload, while strategic maritime routes became increasingly vulnerable to international conflict. For Beijing, depending entirely on the ocean had become too dangerous. The proposed solution sounded futuristic. Create a new infrastructure capable of merging ocean routes, railways, and industrial centers into one continuous corridor. It would not be just a bridge or a railway. It would practically become a new geography built by human hands. The project included giant maritime platforms capable of functioning as autonomous mini-cities, automated cargo systems, and railway lines crossing regions where temperatures drop to dozens of degrees below zero. In theory, freight could move across entire territories at speeds never seen before. The problem was that researchers quickly realized they were attempting to build in some of the most unstable environments on the planet. In the ocean, sensors began detecting underwater currents, capable of exerting pressure equivalent to thousands of tons of water, crashing continuously against any fixed structure. In Tibet, teams discovered something even worse. Beneath the frozen surface was an unstable mixture of ice, mud, and rock, slowly shifting position with the changing seasons. Building there meant supporting trillions of dollars on ground that literally moved beneath their feet. The first signs of danger appeared during maritime tests. Chinese engineers installed experimental platforms in areas considered relatively stable within the South China Sea. The objective was to test gigantic structures that would eventually serve as the foundation for industrial ocean cities. On paper, the idea looked brilliant. The platforms would support thousands of people, store fuel, and operate automated cargo systems. But only months after testing began, something strange started happening. Sensors recorded abnormal vibrations in the structures even on apparently calm days at sea. The platforms swayed in unusual patterns, as if something enormous was pushing against their foundations beneath the water. At first, engineers suspected mechanical failures. Then the divers went down. What they found shocked even veterans of ocean engineering. Beneath the surface were crossing underwater currents forming invisible rivers flowing in opposite directions. While surface water moved slowly northward, deep currents pushed millions of tons of water southward with brutal force. This created extremely unstable pressure zones capable of slowly twisting gigantic metal structures without anyone noticing. In some areas, the speed difference between ocean layers became so intense that instruments began registering movements similar to small earthquakes. And the worst was still to come. During a winter night, one of the experimental platforms completely lost communication. When rescue teams arrived, they found part of the structure tilted and several modules destroyed. There were no signs of explosion, no recorded storm, only deep marks of metal deformation, as if the ocean itself had slowly squeezed the structure until it collapsed. From that moment on, some engineers began defending a radical idea. Perhaps gigantic fixed structures could never survive for decades in that environment. Perhaps the ocean was revealing a physical limitation that not even the most advanced materials on Earth could overcome. Meanwhile, thousands of kilometers away, another team faced a completely different problem in the high-altitude regions of Tibet. China had already built impressive railways across mountains before, but this new strategic corridor demanded something far greater. The plan was to cross regions above 4,000 meters in altitude, connecting inland logistical centers to the future oceanic structures. That meant building tunnels, suspension bridges, and railways across some of the harshest geological regions on Earth. Thin air made machines difficult to operate. Workers suffered from oxygen deprivation, constant dizziness, and temperatures capable of freezing metal equipment overnight. But the true nightmare began when thermal studies started. Scientists discovered that much of the Tibetan ground rested on permafrost, a layer of frozen soil preserved for thousands of years. The problem is that it remains stable only while frozen. Any change in temperature transforms the terrain into an unstable mass of mud, rock, and underground water. This created a terrifying paradox. To build the railway, engineers needed gigantic machines that naturally heated the surrounding ground. But the more heat construction generated, the more the terrain slowly began sinking. In some areas, sensors recorded movements of centimeters per week. That may sound small, but for high-speed railway systems, it represents a catastrophic threat. So engineers attempted an unprecedented solution. They created underground refrigeration systems to keep the soil permanently frozen. Special pipelines were buried beneath the tracks to remove heat from the terrain. For a while, it seemed to work, until new seismic data revealed something far more frightening. The mountains of Tibet were not simply thawing, they were moving. Geological teams then began comparing seismic data from Tibet with measurements taken from maritime platforms along the Chinese coast. What they discovered seemed too absurd to be real. The regions where the megaproject was being developed were part of a gigantic geological stress system stretching across thousands of kilometers of the Asian continent. Oceans, mountains, and plateaus that appeared completely disconnected were actually being affected by the same deep movements within Earth's crust. The Himalayas exist because the Indian tectonic plate continues colliding slowly against Asia after millions of years. That colossal pressure is still happening right now. The Tibetan plateau rises only a few millimeters each year, but that movement continuously accumulates underground energy. The problem is that no modern mega-project was designed to operate for decades on territory literally being compressed by the planet itself. As scientists deepened their studies, they found even more disturbing signs. Some areas contained underground microfractures slowly growing beneath future railway lines. Tiny cracks invisible on the surface, yet capable of causing massive displacement if activated by earthquakes. And earthquakes in that region are far from rare. Western China is part of one of the most seismically dangerous zones on Earth. Entire cities are built under special protocols because tremors can emerge almost without warning. This forced engineers to confront an uncomfortable question. How do you build permanent infrastructure on territory that never stops moving? Along the coast, the problems also began escalating into something terrifying. Climate satellites started recording abnormal storm formations near the future ocean cities. The South China Sea was already famous for violent typhoons, but the new data suggested something different. Gradually warming waters were making weather systems increasingly unpredictable. Storms suddenly changed direction, intensified within hours, and struck areas considered safe by traditional meteorological models. This created a dangerous scenario for gigantic structures installed over the ocean. Unlike conventional oil platforms, those future artificial cities would be far larger, heavier, and completely dependent on constant stability. Any structural failure during an extreme typhoon could trigger a devastating chain reaction. In simulations conducted by Chinese maritime research centers, the partial collapse of a single platform generated secondary waves capable of striking nearby structures, creating a domino effect in the middle of the ocean. For the first time, authorities quietly began discussing mass evacuation scenarios for future maritime installations. And then something happened that increased tensions even further. During one storm season, ocean monitoring drones disappeared one after another near one of the selected expansion zones. Teams initially suspected communication failures until part of the equipment was recovered days later. The hulls were severely deformed by extreme pressure, despite being designed to withstand enormous depths. That raised a disturbing hypothesis among oceanographers. Deep underwater currents might be creating compression zones far more violent than sensors had originally predicted. But something even worse was waiting for the engineers. Something hidden not in the storms, but beneath the ocean floor itself. The most critical moment began when maritime teams initiated deep drilling operations to study the stability of the seabed where future artificial cities would be anchored. As drilling equipment penetrated hundreds of meters below the ocean floor, sensors began detecting something completely unexpected. In certain regions, the underwater soil was not solid as models had predicted. Instead, enormous layers of compressed sediment behaved almost like unstable fluid. It was like trying to support a gigantic structure on top of a mixture of sand, mud, and gas, trapped under extreme pressure. The danger of that is difficult to even imagine. When extremely heavy platforms are installed over unstable sediment, small continuous vibrations can trigger a phenomenon called submarine liquefaction. The ground instantly loses resistance and begins moving like a slow underwater avalanche. In other words, entire ocean cities could partially sink without any visible warning on the surface. And there was another even more disturbing detail. Some analyzed areas contained enormous methane gas pockets trapped beneath the seabed. If deep drilling reached those regions incorrectly, it could trigger underwater explosions or localized geological collapses. The situation worsened when a research team detected subtle underwater displacement near one of the project's priority zones. Sonar images revealed gigantic scars across the ocean floor, evidence of ancient submarine landslides that had occurred thousands of years ago. That meant certain parts of the seabed had already collapsed in the past due to geological instability. For the first time, internal reports began considering the possibility that some areas were simply unviable for permanent structures, but abandoning entire regions would completely alter the logic of the mega-project, increasing costs by tens of billions of dollars. In Tibet, the situation was also escaping the limits of the original calculations. Underground refrigeration systems designed to keep the soil frozen started failing in extremely elevated regions. At first, it appeared to be normal operational wear caused by severe climate conditions. But new studies revealed something far more alarming. Gradual atmospheric warming at high altitudes was accelerating the thawing of permafrost much faster than predicted years earlier. That meant the environment itself was changing while the mega-project was still under construction. Areas that once remained frozen nearly year-round began partially thawing during summer. The consequences for railway engineering were devastating. Entire sections of terrain slowly began sinking, tilting or developing invisible cracks beneath metal structures. Monitoring teams started working 24 hours a day, observing sensors installed along future railway lines. Then came the first major scares. In one isolated mountain region, a group of experimental pillars showed abnormal displacement after a sequence of underground microtremors. It was not a destructive earthquake. The movements were almost imperceptible to humans, but they were enough to slowly alter the stability of the foundations. That terrified engineers because it revealed a brutal truth. The challenge was no longer simply building the structure. It was keeping it alive for decades inside an environment constantly changing around it. The more the studies advanced, the more the megaproject stopped resembling traditional infrastructure and started looking like a permanent battle against a transforming planet. Oceans warming, mountains shifting, frozen ground melting, underwater currents endlessly pressuring gigantic structures. As years passed and billions of dollars continued flowing into that colossal corridor, a silent conclusion began emerging inside Chinese research centers. The project's true enemy was not merely the ocean, the mountains, or earthquakes individually. It was the simultaneous combination of all of them on a planet changing faster than scientific models could predict. Specialists started seeing the project not as simple infrastructure, but as a gigantic experiment taking place inside the extreme environments of modern Earth. In some coastal regions, rising sea levels were already forcing engineers to redesign entire platforms before construction was even completed. In mountainous areas, thermal sensors recorded constant changes in permafrost behavior year after year. The most frightening part was that none of these phenomena happened separately. Everything seemed connected. Warming oceans altered storms. Storms accelerated coastal erosion. Rising temperatures affected underground ice in the mountains. Small environmental changes slowly began producing chain reactions on structures designed to last generations. That forced Chinese authorities to discuss extremely delicate scenarios. What would happen if entire sections of the corridor required constant reconstruction? How expensive would it become to maintain ocean cities inside an increasingly aggressive environment? Those questions never appeared publicly in the grand state television broadcasts. The world saw cinematic images of gigantic bridges, futuristic trains, and glowing maritime platforms resembling cities of tomorrow. But behind the scenes, scientists were discussing something far deeper. Perhaps humanity has reached the point where technology and money are no longer enough to impose total control over nature. Perhaps there are physical limits no world power can cross without unpredictable consequences. Even facing all those risks, the project was never abandoned. And perhaps that is the most impressive part of the entire story. China keeps moving forward. New technologies are being developed to create flexible maritime structures capable of absorbing ocean movement instead of rigidly resisting it. Engineers are working on intelligent materials capable of surviving extreme deformation without losing stability. Artificial intelligence systems monitor climate changes, structural tension, and underground movement in real time across thousands of kilometers. The goal is no longer to completely dominate nature. Now the idea seems far closer to learning how to survive within it. And that changes everything. Because for centuries, humanity built cities believing the planet was a fixed and predictable foundation. But oceans, deserts, mountains, and glaciers are proving the exact opposite. This Chinese mega-project has transformed into something far greater than a trade corridor or a multi-billion-dollar construction effort. It has become a symbol of the confrontation between human ambition and planetary natural forces. A terrifying reminder that the larger our constructions become, the more dependent we are on environmental systems we still only partially understand. And perhaps that is exactly what makes this project so fascinating. It is not merely a story about engineering. It is a story about the limits of modern civilization, about the moment when gigantic machines, artificial intelligence, supercomputers, and billions of dollars encounter something far older, far more powerful, and completely indifferent to human presence, the planet itself. And now I want to know your opinion. If you had unlimited power and money, would you continue a project like this knowing that nature itself seems to be fighting against it? Comment below which impossible mega-project you would like to see in the next documentary on the channel. And if you enjoy stories about extreme constructions, engineering mysteries, and the limits of human civilization, subscribe now to Monolith Discovery, because the next videos will explore projects that seem to come directly from an impossible future.